It's been a little while for those of you who might recognize me. I am not BremSter. I am Lumos, or at least that's my setting name. I am here as a guest solver, and I've been on the channel a couple of times before, so I'm pretty excited to be back. I'm here because BremSter asked if I'd like to solve a puzzle again, and I loved doing it the first couple of times, so figured why not. I guess that's kind of all the news for me. It's been a while, but I'm excited. So I will be solving Anathema, which was a puzzle designed by our very own BremSter. And I guess without further ado, I will go ahead and give the rules, right? So normal Sudoku rules apply, which means that in every box, in every row, in every column, we must have the digits 1 through 9, and they must appear once, and they must not repeat. Also, we've got thermometers, which means along thermos, digits must increase from the bulb end to the tip end. So, for example, this could be 1, 2, 3. They do not have to be consecutive, though. Like if I wanted to go like 3, 7, 9, that would work just fine. So that is an important rule there. And then also we've got something like XSums. So clues outside the grid, like this 10 or this 8 up here, give the sum of the first n digits in their row, column, or indicated diagonal. So that would mean that, like, if I put a 3 here, then the first 3 digits in this row have to add up to 10. So these 2 digits would need to add up to 7. Let's say I made them, I don't know, like 2 and 5. So this would satisfy this rule. Or if I were going up here and let's say the digit were 2, then the first 2 digits in this column would need to add up to 8. So 2 and would be there, and I would have to make this a 6. And that is, I believe, all of the rules that I've got here. So I think I'll go ahead and restart and let's go. So first place I want to start is this super long thermo here. Like, we've got a lot of digits affected, and these will... Okay, so one way to think about this is that I've got 5 digits, which all must be greater than this digit. So the maximum that this digit could be is 4, and all of these would fill in 5 through 9. So I could say this could be 2, 3, or 4, and this could be 1, 2, or 3. And if I wanted to keep going with that, I think I would end up marking kind of a lot here, but I'm okay with that. That's kind of how I solve. So let's see, we'll fill in the result. Let's see, 4, 5, 6, 7, 8, and then 5, 6, 7, 8, 9. I'm also filling in the digits on the other thermos of this length. So I'll go ahead and also just go ahead and mark those up. 4, 5, 4, 5, 6. And there's, I guess, a lot of ways that I could solve a thermo. Some people mark them all up. I'm one of those people, and then some people don't. But that's, everything is a-okay. Let's see if I want to see how these XSums might interact with the thermos. So we kind of got this same pattern up here, like up here with this 10 and 10 and this long thermo and this short one. Got the exact same pattern reflected over here. So if I can figure out what's happening with one of them, should be able to figure out what's happening with both, right? Let's see. So the highest digit that I could put in this XSum for this 10, I'm going to just start here because I'll just pick one. Could be a 4, right? And then the rest of them would have to add up to 6. It would go 1, 2, 3. But I can't put a 4 here because it would have to go out to this digit. And then the lowest this digit could be would be 5. And then I would have 9 and have to add up to 10, like with 1 more in 2 squares, and that wouldn't work. So this is at most 3 and at least 2, because I also can't put 1 here because 1 does not add up to 10 in one cell. So this could be 2 or a 3, and if it's a 2, we'll put an 8 here. 2 plus 8 will make 10, and if it's a 3, then I'll need to add up to make 7. So I'll have to do, like, it can't be 3, 4, but I could do 3 and then 2 and 5 here, or 3 and, what did I say, 3, 4, 2, 5. I could try 1 and 6. So I think we have the exact same pattern here. So I'll just go ahead and fill that in the same way. And what does that leave this to be? I feel like that ends up restricting. So like I've kind of created this 1, 2, 3, 8 quadruple. Like I know one of these makes 3 in 2, and one of them makes makes 10 in 2, and one of them makes 10 in 3. Could be in either order. So that means that whatever this is, it's going to have to pair up with one of these cells to add up to 7. So it'll either be 5 or 6. Yeah, so like 5 plus 2 would make 7, 6 plus 1 would make 7, and then one of these is a 3. So I think that'll have an effect on this thermo. Like this can no longer be a 4 because 4 is not greater than anything. It also can't be a 5. And then this can't be a 5 or a 6. And then let me check to make sure that's, yeah. Okay. And I bet I'm going to run into the same thing over here when I try to do the same thing. So this is also going to be 2, 3. This will be 1, 2, 8. And here will have to be something that would add to 7. So it'll be 5 and 6. And that will affect what these can be. Like this can't be 6. This can't be 5. This can't be 4. Or 5, and then this can't be 5 or 6. 5, 6, 7, yeah. And let me go ahead and clean these up because I didn't clean these up either. So this can't be a 6, and then this one can't be a 5. Okay. Looking good so far. I'm taking a look at these cells because it's pretty close to being 1, 2, 3, 4, 5 quadruple, but this 8 kind of throws a wrench in it. So not quite what I'm looking for. Oh, wait. So this 2, 3 pair that I put in both of these spots actually knocks out 2 as a contender here and here. So basically I'll pull a 2 out of here because, yeah, 2, 3 pair means that neither of these could be 2. Same thing here. And then that will mean that whichever way this goes, this could either be 2, 8, or 3, and then 1 plus 6 to make 7. This would have to be a 6. And I think the same thing happens down here. So this is no longer able to be 6, and then this one can no longer be 7. I'll do the same down here. Okay, I'm liking this so far. I think, oh wait, I've got an 8, 9 pair across this column, so this can't be 8. That's kind of nice. All right, I think I'm gonna work on this 8, because there's only one way I think this can work out. We can't be a 1 because 1 does not equal 8. I could do 2 and 6 because in 2 cells we make 8 with 2 plus 6. And then this can't be a 3 because if I put a 3 here, the lowest digit I could put here would be 8. And 3 plus 8 is 11, which totally is over that total. So actually this is 2 plus 6, which gives me the makeup of all of these cells. Because this 2 looks over to make this a 3, which makes this a 1. So now we've got 3 plus 1 plus 6 is 10. And then this will be a 2 and 8. And we've got 2 plus 8 is 10. And so now I can pull 8 out as an option here, and we've got 7 and 9. All right, this is working really well. This 1 and 3 both look down, so I can pull 3 out there, and I can pull out a 1 here. So I've actually got a 2, 4 pair on the column, so that makes this a 5. Look at that. 5 looks over, so that's not a 5. So the rest of these digits are going to be a 7, 8, 9, a triple. Okay. And this 6 tells me there can't be a 6 there. And oh wait, this 9 looks down to make this an 8, makes this a 7, which makes this a 1, and then 6 plus 1 is 7, plus 3 is 10 in 3 cells, and then 2 and 8 make 10 in 2 cells. So then I can pull out 2 here. I think that's as far as I can go with that. This is not a 7. Let's look over at this 9. Since I've solved pretty much all the XSums on that aren't on this diagonal, like this 17, let's take a look at this 9 and see if I can get similar luck. So it could not be 1 because 1 does not make 9. It could be 2 and 7 to make 9 in 2 cells. And because of this 3, I actually cannot put a 3 here. And then 4 doesn't work because at minimum in 4 squares we would make 10. So actually this just goes 2 and 7, and that is resolved. And then this 2 looks over to make this a 4, and this 4 looks back to make this not 4. And this 4 will look down to make this a 2, and then 2 is not here. Let's see what's left of this triple in this row. 1, 2, 3, 4, 5, 9. Okay. Oh, wait. 3 is not lower than 2. So this is 1. 1, 2, and then this looks like it's still got plenty of options. So yeah, this 4 says that this is not a 4. These ones both look over, so there's a 1 somewhere down here. And then these are all made up of the same digits, 4, 5, 7, and 9. And then as for this thermo, this could not be 7 or 9. It would have to go like 4. Well, blah, blah, blah. This could be 4. This could not be a 4, and this could not be a 5. And then this could not be a 9, and this could not be a 4. That's just because of the thermo rules. They have to increase. So I can't have 4 at the end of the thermo because there's nothing lower than it. And I can't have 9 at the bulb because you can never have 9 in the bulb of a thermo. So, and that'll be the same pattern down here. 4, 5, 5, 7, 7, 9. 8 means this is not an 8. And I do know that there's an 8 down here somewhere, but it's not here. One of these 2 is a 2. Figured I should play a little Sudoku for a bit, so let's fill in what we know. One of these 2 is a 2. I can place a 2 right there. That's really nice. And I think, yeah, I can place a 2 right here at the end of this thermo. Because of this 2 looking over, this 2 looking down, and then 2 can't be anywhere on this thermo because this thermo has to strictly increase, and we've already got a 2 on it. So this is a 2, which makes this a 1 because it's the only digit lower than 2. And that will look over to make this a 3. And then this 3 means that this is still a 4 or 5. So then this 1 tells me that this is not a 1. Oh, and I can place the 3 for this, kind of similar to what I did with 2, where I'm just using Sudoku. This 3 looks up, this 3 looks up, this 1 looks over, so this is a 3. Then these 3s look over, 3's going to go somewhere over here. You know, I've got a 6 somewhere on this thermo, because both these look over and then this one looks up. And same down here, there's a 6 somewhere on this thermo. Not quite as restricted as the one at the top. One of these 2 is a 7 because this 7 looks up and this one looks down. I think that's all I got there. And then I think I might have I did the 8s already, and I think I've only got one 9. Okay, yeah. Okie dokie. Let's take a look at this 17 diagonal. I think I can't avoid it for any longer. Let's see. Well, I could work on this thermo a little bit, right? So the minimum digit this could be would be 3. Yeah, because I've already got a 1 and 2 in the box. That's actually not wildly helpful, but if I just, I don't know, I guess I could fill it in all the way. That would be a lot of digits. Let's focus on this cell and what happens on this 17 diagonal here. Okay, so at minimum, this cell is a 5 because I could go 3, 4, 5. So that's the minimum value there. I could do 6, 7, 8, or 9. But let's think about how that would actually work in terms of the diagonal itself. So if this were a 9, I would have to use all the digits on this diagonal to add up to 17. And I think even at minimum, like that's not going to work. So because I would already have a 9. So I would have 9, 10, 11, 12, 13, 14, 15. And I would need to make 17 in 4 cells when I'm already at 15. And that's way too high. So this definitely could not be 9. And I think it can't be 8, same reason. That would be 8, 9, 10, 11, 12, 13, 14, 15, 16. And I still have 2 cells left and I need to make 17. So 8 also does not work there, which actually places an 8 down here. So that's kind of nice. So this is either 5, 6, or 7. Let's see if it's 5. Let's try from the other end. 5, 6, 7, 8, 9. Then I would have to add that 9 plus 8 equals 17, and none of these can be 8. So this also can't be 5. Ooh, cannot be 5. So this is 6 or 7 so far. We've got, let's test out both those options. So if this is 6, 6, 7, 8, 9, 10, 11, 12, and this would have to be 5 to, 6 plus 6 is 12 plus 5 is 17. Good. Okay. And then if this were 7, I would have to do 7, 8, 9, 10, 11, 12, 13. And I'd have to make 4 with these 2 digits. So it would be, a 1, a 3, or a 2 and a 2, but can't be 2 and 2 because both boxes already have 2s in them. So it'd have to be like 3 and 1. Yeah. So those are my current possible options. And I think that's all I can do for right now, right there. So, but that's good information because I've definitely narrowed some things down. Because it also, let's see, that means my 9's somewhere out here. I know that 3 is definitely on this thermo, and it has to be the minimum value. Just because 1 and 2 are the only things that are lower than it, and they're both on a different thermo than this one. So 3 has to be, if 3 is forced to be on this thermo, then 3 has to be at the bulb. So that means that this is something in between 3 and 6 or 7. So 3 could be 4, 5, or 6 there. These 3s are both looking over, so they tell me that there's a 3 down here. This 3 looks up, this 3 looks down. Oop, this 3 looks down, and this one looks over. So we've got 3 is restricted to these 2 cells, and it's the same 2 cells that 2 is restricted to in this box. We've got a 2-3 pair here. And I think, oh, never mind. Oh, wait, this 2 looks over, so that's not a 2. This is a 3, which actually makes me want to go back and check that real quick because I didn't see that earlier. Yeah, this is not a 2. This one look up. This one looks down. Yeah, that's a 2, and then my 3's up, down, over. Yeah, that's a 3. These 3s are both looking over. That restricts 3 to down here. So 3 goes right here on this thermo. And because we already solved that out, the 3 goes with the length 7 XSum. So this is a 7. And then that means I need this to be a 1. And this can still be 4, 5, or 6. Except that I don't think 6 can go anywhere else. Yeah, 6 can't go anywhere else in this box. So that's a 6. And then the 7 is making this a 9. This 8 and 9 are making this a 7. So we'll take 9 out here, which actually makes this a 9 because of the 4, 5 pair in the row. This 9 looks over, so this is not a 9. And then that requires that the 9 be here because we can't put it on the bulb. So 9 there in box 9. Don't think there's much else with that, but this is not a 9, which means that this cell is not 8. And we know 9 is somewhere here in this box. No, 1 is somewhere up here, and it's sort of making an X wing with the ones down here in the bottom. And this 3 looks down, so this is not a 3. 3's in one of these 2 cells. This 3 also looks up, so I know this is not a 3 here, which means that this is a 3, and then this 3 looks down to tell me that's not a 3, and this one is. I think all that's left in this row is 1, 4, and 5. I don't have any way to resolve that, but I know that there's a 1 somewhere here. What's left here? We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, and then I know that this is not 6 or 8 or 1, so that makes this a 9. Okay, lovely. So it's not a 1, and then none of these are 9s. And this 9 looks over, telling me that's not a 9, so we'll put a 9 at the end of this thermo. And pretty much anything can go between 3 and 9, so these are still unresolved. This is going to be a 5, 6, or 8. And that makes a 5, 6, 8 triple, so I can pull 5 off as an option here. And then this will be 4, 7 as a pair. And that means that this cell is known. So we've got 1, 2, 3, 4. This is 5. Okay. So 5 looks over, so neither of these are 5, which makes this a 7. And the 7 makes this a 4, and this 4 makes that a 5. This 5 looks over, telling me I've got a 1, 4 pair here, and then to finish the box, in terms of pairing things up, I'll have a 2, 6 pair. But this 2 resolves it, so 2 looks down, telling me that's a 6, and then this is a 2. 6 looks up, telling me that's not a 6. Oh wait, look at this. The 7 looks up. It's been here forever. Tells me that's not a 7, and that's not a 7. So that'll make this a 9. This a 9. This is a 5. This is a 4. And then the only thing left in the box is 7. This 4 looks down to make this a 5. And then this 5 makes this a 4. These 9s are both looking over. And then this one looks up. So only cell left to make that a 9 isn't, well, there. And then this one looks down. This one looks up. And this one looks over, so this is a 9, and I think that finishes off the 9s. Yeah. This 7 looks over to tell me that's a 4, and this is a 7. Gotta play Sudoku when you're playing Sudoku. 7s look over, these 7s look up, so this is a 7. And I think that finishes the 7s. Okay. We are very close to breaking this whole thing. This 4 tells me that this is a 5. And then this is a 1, 6, or 8 according to what's needed in the row. It's not a 1, and then this is going to be a 6 or an 8. One, 6, 4, or 8. This one's not. Oh wait, this was just sitting here. This is a 4. Didn't mean to do that, but that's a 4. And then this is not a 4. What's left in this row? We've got what, 4, 5? And are either of those resolved? I don't think so. Let's do this row. 1, 2, 3, 4, and 8. Except that I cannot put 8 on this 3, on the bulb of this 3-length thermo. So this will be a 4, making this an 8. This 4 will make this a 5, and this a 4. And then this 4 makes this a 1, making this a 4. This 1 looks up to make this a 1, and then to finish off the box, we'll put a 5. This is going to be a 6, 8 pair, except that we know the order because of the thermo. It has to always increase, so we go 6 and 8. This 6 looks down to make this an 8. This 8 makes this a 1, 6 pair. This 5 looks down to make this an 8. This 8 makes this a 6, and then this a 5. That 8 also makes this a 6, and then why do I have a 1, 6 repair? I don't. Oh, wait, what did I mess up here? Which one of these already has a 6 in it? Oh, this already has a 6. This should be 1, 8 pair. Okay, good. It's briefly very scared. This 6 makes this a 1, and this a 6, and then this 1 makes this an 8, and this a 1. And that is Anathema by BremSter. I thought this was a really cool puzzle. I really loved the symmetry of these 10s here and how they interacted with these long thermos. I think that was kind of like a pretty good solid break-in, especially because I don't know, I like immediately looking at this, I was thinking, oh, this long thermo is probably going to be where the break-in is, and maybe there's a way to have solved this whole thing faster, but no, I think the way that it turned out is exactly the way it should have. I really liked these 10s doing a lot of work. I think this was really cool. I really enjoyed this one. I love a good puzzle. And that's all from me. Thanks. It's nice to see you.